Da Vinci and his art remain an enigma, full of clues to deeper stories he told through his paintbrush.
View of Leonardo da Vinci's masterpiece. Simply breathtaking.
Literally revealing Leonardo's works.
There was once a man. He wrote backwards. Every single word, reversed, running right to left across the page, in a handwriting that could only be read properly in a mirror. He filled more than 7,000 pages with this strange, coded script. And then he told nobody. He published nothing. He just stacked the notebooks in his studio and kept working. When Leonardo da Vinci died in 1519, his life's work, the real work, not the paintings, not the Mona Lisa, not the Last Supper, but thousands of pages containing ideas so advanced they shouldn't have existed for another 300, 400, 500 years, passed quietly to a young pupil named Francesco Melzi. And then, slowly, those notebooks began to disappear. Pages were stolen. Volumes were dismembered. Entire codices were lost for centuries. Some were seized by Napoleon. Others ended up collecting dust in a library in Madrid, where 2 notebooks were rediscovered in 1967, nearly 450 years after Leonardo's death, sitting on a shelf where nobody thought to look. To this day, scholars estimate that perhaps only half, maybe as little as a quarter, of what Leonardo actually wrote has survived. And yet, even that fraction has been enough to shake the foundations of what we thought we knew about the history of science. Because what's inside those pages isn't just clever. It isn't just ahead of its time. It's impossible. Or at least, it should have been. Let's start with something that sounds simple. Friction. You push a box across a floor, and it resists. Everyone feels it. But describing the actual laws that govern it, the mathematics, the physics, that took science until the late 1600s. A French scientist named Guillaume Amonton gets the credit. Every physics textbook says so. Amonton's laws of friction. Except that in 2016, a Cambridge University professor named Ian Hutchings looked at a page in one of Leonardo's notebooks, a tiny book, barely bigger than a book of stamps, 92 millimeters by 63, now held in the Victoria and Albert Museum in London, and found something extraordinary. A set of rough sketches in red chalk, previously dismissed by an art historian in the 1920s as irrelevant scribbles, turned out to be the first written record of the laws of friction in human history. The sketches showed blocks being dragged across surfaces by weights hanging over pulleys. The accompanying mirror-written text laid out exactly the same principles Amonton's would be credited with 2 centuries later. Friction doubles when weight doubles. Friction is independent of the area of contact. Leonardo had it all, in 1493. And he didn't stop there. Hutchings' research showed that Leonardo applied this knowledge for more than 20 years, using it to analyze wheels, axles, screw threads, pulleys, every kind of mechanical element he drew. He understood lubrication. He experimented with different surfaces. He grasped concepts that the formal science of tribology wouldn't name until the 20th century. All of it scribbled in the margins of notebooks that nobody would read for 400 years. But friction is just the beginning. And honestly, it's not even the part that keeps scientists awake at night. Let's talk about the heart. Because what Leonardo did with the human heart is the thing that genuinely crosses the line from impressive into territory that feels almost eerie. In the early 1500s, Leonardo began dissecting human bodies. Over his career, he performed roughly 30 human dissections, working in monastery hospitals and medical schools, often by candlelight, with no refrigeration, no preservatives, cutting into flesh that was already decaying. And what he drew was so precise, so detailed, that modern anatomists have used his 500-year-old sketches to teach anatomy today. He was the first person to correctly identify that the heart has 4 chambers, not 2, overturning a medical belief that had stood unchallenged since the 2nd century. He was the first to describe atherosclerosis and cirrhosis of the liver. He described the coronary sinuses nearly 200 years before the man who eventually got them named after him. He came breathtakingly close to discovering the circulation of blood, more than a century before William Harvey published his landmark work. But here's the part nobody saw coming. Deep inside the heart, lining the walls of the ventricles, there's an intricate mesh of muscle fibers called trabeculae. They form complex, branching, snowflake-like patterns, fractal patterns. Leonardo was the first person in recorded history to sketch them. He drew them in exquisite detail in his notebooks and speculated that they warmed the blood as it flowed through the heart. He was fascinated by why these mathematical patterns kept appearing in nature, in trees, in rivers, in the vessels of the human body. He even formulated what's now known as Leonardo's rule for branches. For 500 years, nobody could figure out what trabeculae actually did. Leonardo's guess about warming the blood was noted and set aside. The fibers were treated as a developmental relic, something the heart needed as a fetus but not as an adult. A biological mystery with no answer. Then, in 2020, a team of researchers from EMBL, Cold Spring Harbor Laboratory, and the MRC London Institute of Medical Sciences published a study in the journal Nature that finally cracked it. They used artificial intelligence to analyze 25,000 MRI scans of the heart, combined with genetic data from 50,000 patients with heart failure. And what they found was stunning. The trabeculae that Leonardo sketched 5 centuries ago aren't decorative. They aren't vestigial. They're critical. The rough, fractal surface they create inside the heart traps a thin layer of static blood along the organ's wall, reducing friction between the heart muscle and flowing blood, making each heartbeat more efficient. Like the dimples on a golf ball trapping tiny pockets of air that help it glide further through the atmosphere. And different fractal patterns in these fibers actually affect a person's risk of developing heart failure. Leonardo couldn't have known any of that. He didn't have MRI machines, or AI, or genetic databases. But he looked at those fibers, drew them, and knew they mattered. He was right. It just took the rest of humanity half a millennium and the most advanced technology ever built to catch up. Declan O'Regan, the clinical scientist who led the research, put it plainly. Leonardo sketched these intricate muscles inside the heart 500 years ago, and it's only now that we're beginning to understand how important they are to human health. And this is the pattern. Over and over, across every discipline Leonardo touched, the same thing happens. He sees something, he draws it, he writes about it backwards, and then science takes centuries to arrive at the same conclusion. He designed an experiment to measure gravitational acceleration, roughly 100 years before Galileo demonstrated gravity's universal effect on objects, and long before Newton and Einstein used calculus, which hadn't been invented yet, to define and explain it. He conceptualized the parachute, the helicopter, concentrated solar power, the armored vehicle, and the double hull. He produced the first modern technical drawings, including the exploded view diagram, a technique still used by engineers today. He studied hydrodynamics so obsessively that he used colored dyes in rivers to track flow patterns, noting that water moves faster in the center of a channel than at the edges due to friction against the banks, a principle of fluid dynamics that wouldn't be formally described for centuries. He built a glass model of the human aorta and pumped water seeded with grass through it to watch how blood flowed across the aortic valve. In 1969, a scientist named Bellhouse published a landmark paper describing sophisticated experiments on the mechanics of the aortic valve, using transparent models and tiny particles suspended in water. The scientific community was impressed. Then someone pointed out that Leonardo had done the exact same experiment with the exact same methodology 450 years earlier. And here's what haunts researchers most. He never published any of it. Why? That's the question that has no clean answer. Some historians believe his mirror writing was a deliberate encryption designed to protect his ideas from the church or from competitors. Others think it was simply a practical habit, a left-handed man avoiding smudged ink. But the result is the same. His discoveries went unpublished for more than 400 years. Entire branches of science had to be rediscovered from scratch by other people, decades or centuries later, because the man who figured it out first wrote it backwards in a notebook and put it in a drawer. Near one of his drawings of the heart and blood circulation, Leonardo wrote a line that has troubled historians ever since. He wrote, "I could tell more if I was allowed to do so. That's it. No explanation, no context. Just a man who understood more about the human body than anyone alive in his century, admitting on paper that he was holding something back. And we still don't know what it was. Think about what that means. The pages we have, the 7,000 or so that survived theft, neglect, water damage, Napoleon, and 4 centuries of obscurity, have already rewritten the history of friction, anatomy, fluid dynamics, engineering, and cardiac science. They've already proven that one man, working alone in Renaissance Italy, with no formal education, no university degree, nothing but candlelight and curiosity, anticipated discoveries that the rest of the world wouldn't make until it had microscopes, computers, and artificial intelligence. And those pages might be only half of what he wrote. In 2005, researchers in Florence uncovered what may have been Leonardo's secret workshop, hidden behind a staircase in the Santissima Annunziata convent. In 1967, 2 lost codices turned up in Madrid. Every few decades, something new emerges. A page, a sketch, a connection that nobody noticed before. And each time, the same realization hits. He already knew. The notebooks of Leonardo da Vinci aren't just historical artifacts. They're evidence of something that doesn't fit neatly into how we understand the progression of human knowledge. A man who saw further than anyone around him, who understood things that his century lacked the language to describe, who sketched the future in mirror writing and then locked it away. What he knew 500 years ago wasn't just ahead of its time. For the world he lived in, it was impossible. And the terrifying thought isn't what we've found in his notebooks so far. It's what might still be missing.